4-bit adder. 4-bit adder. Now let me know if we are in that decimal numbers. Let us in that 13 plus 11. Okay. So in decimal, how you are doing the addition, or let us in that we are having that. Okay, fine. So I am having that 13 plus 9. 13 plus 9. So this is my decimal addition. Okay. So in decimal addition, how we can do it? 13 plus 9. So first we add LSB. So what my LSB is? 3 plus 9. How much? 3 plus 9? 12. Very simple. Now, what here? Out of 10, it is a single digit addition. This is my single digit. It is also my single digit. So 3 plus 9 is, the answer is 12. Is it right? The answer is 12. But 12 is 2-digit number. What we are adding here? We are adding here that single digit number 3 plus 9. So 3 plus 9 is 12. But 12 is your 2-digit number. That's why we just take here that 2. And what we are doing? We are carrying the 1 here. We add here that 1. Clear? We add here that 1. So 1 plus 1, 2. 2 plus 0, 2. So the answer is 22. Very simple. This is of your decimal additions. Now what the binary of 13 is? What the binary equivalent of 13? Is that anyone know? Binary of 13? Bhakti, Mayuri, Mandar, Diksha, 110. Akshar, very correct. 1, 1, 0, 1. Okay. Plus. What is the binary of 9? Binary of 9? 1, 0, 0, 1. Very correct. Now let me know how we are doing their addition. हम इसका addition कैसे करते हैं? Yes. So सबसे पहले LSB 1 plus 1. Now the basic rules of the additions are. Okay, I just switch to here another page. So basic rule of addition. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. And 1 plus 1. Sum is 1. Sorry, sum is 0. And what is that? Carry is 1. Here these are my sums and these are my carry. So carry is here that 0. Clear? Is it clear? Yes, sum is 0 and carry is 1. So we are adding which number? 13 plus 9. So what is your 13 is? So 13 is 1101 plus, what is my 9 is? 1001. Clear? Now, first we add LSB. 1 plus 1. Basic rule is 1 plus 1. Sum is 0. So, sum is 0 and carry is 1. So where we have to add this carry? ये carry कहाँ पे add करना पड़ेगा? We have to carry in next successive addition or in next bit addition. Is it right? Yes or no? 1 plus 1, last bit addition is 1 plus 1, LSB is 0, sum is 0 and carry is 1. Now this carry we have to add in successive addition. In successive addition, that means in next bit addition. So here it is 1. Yes or no? Is it correct? Yes. Yes, answer is definitely you will have the answer, but we are looking for the process. Because whatever the process we are having, the same process we are going to implement for your 4-bit adder. जो कुछ भी हम यहाँ पे प्रोसेस चेक करने वाले हैं, वही प्रोसेस हम आगे 4-bit adder में implement करने वाले. Okay. So I am not asking about the answer, no problem. So I am just asking the step by step. So 1 plus 1 is 0, carry 1, where we add this carry. जो कुछ भी यहाँ पे carry generate हुई है वो हमने कहाँ पे add की है? In next addition. Clear? Now 1 plus 0, this 1 plus 0, 1. 1 plus 0, 1. Is that any carry generated? So what is my carry is here? 0. So that will be add in next addition. That will be add in next addition. So 0 plus 1, 1. 1 plus 0, 1. So there is no carry. So the carry is here addition 1. Sorry, 0. So 0 plus 1, 1. 1 plus 1, 0. And there is a carry is 1. Clear? It's a very simple. Let's take another. Let's take here that another example. So we just add here 13 plus 11. हम 13 plus 11 का addition कर. Okay. So let's check. 1 1 0 1 plus what is 11? 1 0 1. Is it right? Okay. We are having two numbers. This is a number A. We can say this is number B. So A is 13 and B is 11. So this number is 1101. This number is 101. Now let me know 1 plus 1. 1 plus 1, 0. Carry 1. So I am just writing the carry by another color. So what my carry is 1. Clear? 1 plus 0. 1 plus 0. Okay. What 1 plus 0? 1. 1 plus 1? 0. Carry. My carry is 1. Correct? Now 1 plus 1? 0. Carry 1. 0 plus 0? 0. Okay. 0 plus 0 is 0. 1 plus 1? 0. Carry. There is a carry. Carry is 1. Okay. Then 0 plus 1? 1. Okay, we just keep this carry in final one. So this is my final carry. Okay. Let's check once again. 1 plus 1. This is a 1 plus 1. 0. Carry 1. Okay. Then 1 plus 0. 1 plus 0 is 1. 1 plus 1. 0. Carry 1. Now here 1 plus 1. 0. Carry 1. Here it is intermediate carry generated. So this carry is forwarded here. Okay. This carry is forwarded here.
मम्मीने रिचार्ज टाकलं.
Hello. Swapnil, are you there? Hello.
Sir,
Hello.
just a minute. Just a minute, sir.
Okay. ठीक.
Okay. Sorry for discontinue. Okay. So, am I audible to you? Oh, okay. So fine. So what here we are going to do? We are just adding the two numbers, 13 and 11. Okay. Then 13 understands? Okay, I just again repeat it. So 13 means 1, 1, 0, 1. 11 understand? 1, 0, 1, 1. Clear? Okay. How we can do their addition? 1 plus 1, 0. Carry, this is my carry. Carry is 1. Okay. 1 plus 0, 1 plus 0. 1 plus 0 sum is 1. 1 plus 1, 0. Carry is 1. Clear? Now here it's a very important. 1 plus 1. 1 plus 1 is 0 and carry is 1. This is the intermediate carry. So this carry will come out here. Okay. Then what is my sum is 0. So 0 plus 0, 0. Clear? 0 plus 0, 0. Now 1 plus 1, this is a carry generated. So 1 plus 1, 1 plus 1, what is that? Sum is 0 and carry is 1. This is the intermediate carry. Now 0 plus 1, 1. And this intermediate carry is coming out. This is a C out, final C out. So this is my sum. This is my C out. Okay. 4-bit addition, always the result is 5-bit. So 1 is my C out and remaining 4 bits are my sum. Any doubt? Very simple additions. Now check their structure. Okay, we are looking for their structural design. So check here what we are doing initially. सबसे पहले हम क्या कर रहे हैं यहाँ पे? Initially we are just adding 2 bits. Is it right? Here we are adding 2 bits. 2 bit. When we add 2 bits, that adder is known as, उसको हम क्या बोलते हैं? कौन सा adder बोलते हैं? When we add 2 bits at time, that adder is known as. कौन से adder का input 2 bit होता है? Yes. When we add 2 bits, that adder is known as half adder. Very correct. Very correct. So we are having half adder. Is it right? Now check here. In second bit additions, we add 3 bits at a time. We add 3 bits at a time. Is it right? So when we add 3 bits at a time, that adder is known as. उसको हम क्या बोलते हैं? When we add 3 bits at a time, that adder is known as. Yes, anyone? Full adder. Very correct. Very correct. Full adder. So this is my full adder. In third bit additions, also we are adding 3 bits at a time. This is the 1 carry and this 1 and 0 are my bits. So this is my full adder. Okay. And also we are adding the last bit with carry. So this is also of your full adder. So do you find that when we do the 4-bit addition, जब हम 4-bit का addition कर रहे हैं, तो actual में हम वहां पे क्या यूज कर रहे हैं? वहां पे actual में हम क्या यूज कर रहे हैं? Full adder. Are you getting it? Are you getting it? Okay. So what do you think? 4-bit adder that understand actually, what actually you understand? Actually it has full adder. Actually it has full adder. Now let me know your design will be uniform if it will have all the full adder. That will be very simple. Because if you are going for cascading connections or 8-bit adder, and you have to use two 4-bit adder, then that means also you can use as a cascading. That is another part that we will talk in later. Now, any doubt here? यहाँ तक समझ में आया आपका? 4-bit adder, very simple concept. 4-bit adder का मतलब क्या है? वहां पे हम एक्चुअल में क्या यूज करने वाले हैं? No sir. What's doubt? Let me know. Is there any doubt? Okay, nothing. Okay, fine. So when we add 4-bit adder, that means actually here we are having a full adder. Now, what here? The first bit is of your 1 and 1. We are adding here that 2 bits, 1 and 1. If you add here 0, is that any effect on your result? अगर हमने यहाँ पे पहला बिट अगर 0 ऐड किया तो यहाँ पे आपको कुछ फर्क गिरने वाला है क्या रिजल्ट पे? नहीं. If you add initially at LSB, there is 0 bit. So is there any effect on your result? No. When we add 0 with anything, that will be same value. Is it right? Yes. So can you consider the fourth one? This is also my full adder in place of half adder. Can we use as a full adder? Are you getting it? It means when we are going for 4-bit adder, actually we are using 4 full adder. Is it clear? 4-bit adder, it means we want to use 4 full adder. 4 full adder. Clear? Is it clear? Yes or no? Yes. Okay, thank you. So when we are having this number A, okay, we are saying that this is my first number is known as, पहले नंबर को मैंने क्या बोला? Number A. Second number को मैंने क्या बोला? Number B. Okay. So 13, their binary equivalent is 1101. So I can treat as the first one can be considered as A of 0 because my number A is 4-bit. मेरा जो फर्स्ट नंबर है A, ये मेरा 4-bit है. उसको मैं कैसे लिख सकता? 3 down to 0 with their index. 3 down to 0. 3 down to 0 इसका मतलब होता है 4 bits. A of 0, A of 1, A of 2, A of 3. Okay. So this is my A of 0. Then it is my A of 1. It is my A of 2. This one is my A of 3. Correct? Similarly, I am having the second number, and what my second number is? B of 3 down to 0. So what my second number is? B of 0, B of 1, B of 2, B of 3. Clear? Okay. So we are trying to understand here. We are going with that 4-bit adder. So this is my 4-bit adder. So what my 4-bit adder is? Simply okay. So this is my simply a black box. Let us in that their name is adder underscore 4-bit. Okay. इसमें मेरा जो पहला नंबर रहेगा इसको मैं नाम देने वाला हूं A और इसकी width size कितनी है? 3 down to 0. So when the variable declared with the size, the bit size, it is known as bus. उसको हम क्या बोलते हैं? Bus. समझ में आ गया? Bus is nothing but simply a group of wires or the variable with size. Okay, number of bits. So that is known as your bus. What my second number is? B. What is my B? 3 down to 0. Okay. Then this is my sum. It is my sum. Okay. So this is my sum of 0. It is my sum of 1. it is my sum of 2 and this is my sum of 3 and this is my final carry, C out. So how many of outputs we are having? How many of outputs you are having? Sum of 3 down to 0. So it is also bus, and the fourth one is, what is that? Sorry, last one is C out. Very simple. Can you draw their block diagram? Yes. It's very simple. Clear? Now let's check what inside it. इसके अंदर क्या है? चेक करते हैं. सबसे पहले चेक करो. A of 3, A of 2, A of 1, A of 0. Okay. B of 3, B of 2, B of 1, B of 0. So सबसे पहले हम क्या ऐड कर रहे हैं? A of 0 add with A of 0 add with B of 0, and there is we default we are taking that the third variable value is 0. So that is known as your C in, or you can call it as C of 0. Okay. C of 0, this C of 0, do you find inside in this block? आपको यहाँ पे जो ब्लॉक डायग्राम दिख रही है, इसके अंदर C of 0 अवेलेबल है क्या? नहीं है. Is it clear? It is not available in this, sorry, it is not available outside of this box. ये box के बाहर C available है क्या? नहीं है. Okay, check it. Then we add A of 0 plus B of 0. What here? The result is sum of 0, S of 0, and there is a carry. So this carry can be called as, ये carry को हम बोलेंगे C of 1. Clear? So whatever the carry generated from your first full adder, that will be add here. So what your structure will come here? इसमें structure कैसे आएगा? So सबसे पहले हमको लगेगा पहला full adder, जिसको हम नाम देंगे FA0. Okay, it's a FA0. So FA0 को दो इनपुट रहेंगे, एक रहेगा A, एक रहेगा B, and थर्ड इनपुट क्या रहेगा? C in. आउटपुट क्या है? उसका sum and C out. Now, what we are going to have? This is my sum and it is my C out. Okay, let's check. My number is, यहाँ पे एक बार और explain करता हूँ मैं आपको. So my number A is 13. So 13 का equivalent क्या हो गया? 1, 1, 0, 1. What my second number is? B. Okay, so B is my 11. So what is that? 1, 0, 1, 1. Okay. Okay. So this is my A of 0. ये जो मेरा पहला बिट हो गया, ये है मेरा A of 0. ये है मेरा A of 1, सेकेंड बिट. थर्ड बिट को मैं बोलूंगा A of 2. फोर्थ बिट को मैं बोलूंगा A of 3. Similarly, what is that? It is my B of 0. This is my B of 1. It is my B of 2. And this is my B of 3. Clear? So यहाँ पे मैं अभी क्या ऐड करने वाला हूँ? सबसे पहले A of 0 plus B of 0. That means this one and this one. So their input should be, यहाँ पे input क्या रहेगा? A of 0 and B of 0. Clear? A of 0 plus B of 0. Okay. So now let me know. 1 plus 1. 1 plus 1. 1 plus 1 क्या होता है? 0. That will be carry here. Now 1 plus 1 is 0. If you add here 0, is that any effect on your result? अगर हमने यहाँ पे 0 ऐड किया तो रिजल्ट पे कोई फर्क गिरेगा क्या? 0 plus 1 plus 1. 0 plus 1 plus 1. There is no effect on your result. So what here I am setting my C in as 0 value. मैं C in को क्या सेट करूंगा? 0 value. Clear? So let's assume my A of 0 is 1, B of 0 is 1. So 1 plus 1 is sum is 0 and C out is 1. Now यहाँ पे जो कैरी जनरेट हो गया मेरा पहले एडिशन में, जो मेरे पहले एडिशन में कैरी जनरेट हो गया, वो कहाँ पे ऐड हो रहा है? जो पहले एडर में या फिर 1 plus 1 में या फिर फर्स्ट जो नंबर है A of 0, B of 0, यहाँ पे जो कैरी जनरेट हुआ वो कहां पे ऐड होने वाला है? Shirin, Nadat, next MLB. Okay. Next addition. Very correct. Very correct. Next addition. So it means also we need another adder, another full adder. So that's why here I am adding. Here I am adding another full adder. So let's check. This is my FA1. Okay. This is A, B, C in, sum, C out. So this A is connected with, यहाँ पे जो A connect रहेगा, that A is connected with A of 1. This B is connected with B of 1. Okay. Sum is connected with sum of 1. Okay. Now यहाँ पे जो second full adder का जो input carry रहेगा, carry in. Okay. So this carry in is coming from सेकेंड एडिशन में कैरी कहां से आएगा? सेकेंड एडिशन में कैरी कहां से आएगा? प्रीवियस एडिशन से. इज इट राइट? प्रीवियस एडिशन से. सो दैट्स व्हाई व्हाट हियर, whatever the output from first full adder, okay, the C out, that will be add in, sorry, that will be add here. Whatever that output generated from, carry generated from your previous adder, that will be added here in second addition. That will be added in second addition. Is it clear? Is it clear? So similarly, जो second addition में carry generate होगा वो कहां पे add होगा? Third addition में, obviously. So this is my third full adder, FA2. So again it has the input is A, input is B, input is C in, output is sum and C out. Okay. So यहाँ पे हम input कौन से देने वाले हैं? So what my input is here? A को जाएगा A of 2, B को जाएगा B of 2. Okay. Sum will connect with S of 2. Now, whatever the carry generated from your second addition, that will be add in. कहां पे add होगा? Second addition का carry. Second addition का carry कहां पे add होगा? In third addition. Is it right? There is a carry in. This is a carry in. Correct. Very correct. And hence we are on a fourth bit. So we are having the fourth full adder. So this is my fourth full adder. Okay, so that is my input A, input B, input C in. Then there is the output sum and output C out. So this is my FA3. This is my FA3. So output is S of 3 and this is my C out, which is a final C out. Okay, now the carry in for fourth addition, that will be coming from carry out of third addition. Okay, the inputs are connected here as. The inputs are connected as. What is that? A of 3, B of 3, and so on. Clear? Is that clear? Is it clear? Yes? Any problem? Okay. So we are having a 4-bit adder. So that's why we use 4 full adder. So initially we add here first bit A of 0 and B of 0. Okay. Then second bit A of 1 add with B of 1. Then third bit A of 2 add with B of 2. And the last one, that is here we are adding A of 3 add with, what is that? B of 3. Clear? Any doubt? Okay. So if you are looking for your final block diagram, okay. So if you are looking for your final block diagram, so it will look like this. Okay. It will look like this. So if you are making the border of this, okay. So you may find here. Okay. So this is my internal structure of 4-bit adder. Check karo. We are having this model block diagram. So what model block diagram is having? Only inputs A of 3 down to 0 and B of 3 down to 0. Where output is sum 3 down to 0 and C out 3 down to 0. यहाँ पे भी चेक करो, इनपुट क्या है आपका? A of 0, A of 1, A of 2, A of 3. Another input is B of 0, B of 1, B of 2, B of 3. Outputs are S of 0, S of 1, S of 2, S of 3, and the final output is C out. Whatever that the carry generated internally, okay, that will be coming from first adder to second adder to third adder to fourth adder. This carry is repels. This carry is repeated and it will be added in next addition. That's why this adder is known as, इसको हम कौन सा adder बोलते हैं? What it carries? It repels the carry. Okay, it regenerates your carry and it will be added in next addition. So that's why it is known as repel carry adder. It is known as your repel carry adder, that is known as your RCA. Is it clear? So in this repel carry adder, how many adders we add? How many full adders are there? 4-bit में? 4-bit में हमको कितने adder लगे? 4. Very correct. Oh, very correct. So have you understood their internal structure, their block diagram? Have you understood? Yes. Okay. Thank you. Now let me know this C out of FA0, that will be add in C in of your FA1. इसको हम क्या बोलेंगे? जो कनेक्शन है C out to C in, इसको हम क्या बोलेंगे? Can anyone tell me? The connections between C out of FA0 to C in of FA1, ये कनेक्शन को हम क्या बोलेंगे? Carry. Okay, the carry is, yes, it's a carry. But what actually it is defined as? Verilog में इसको हम कैसे डिफाइन करेंगे? Verilog में इसको हम कैसे डिफाइन करेंगे? No, यहाँ पे क्लॉक का कंसेप्ट ही नहीं है ऋतुजा, क्लॉक का कंसेप्ट ही नहीं ना, हम तो सिक्वेंशियल डिजाइन यूज ही नहीं कर रहे ना. क्लॉक का कंसेप्ट कहाँ पे आएगा? क्लॉक का कंसेप्ट कहाँ पे आएगा? सिक्वेंशियल डिजाइन में. ओके, ये तो कॉम्बिनेशनल डिजाइन from Monday onwards, so don't miss the lecture from Monday onwards. We will take their sequential design. That's very important. It's a register. No, it's not a register. A register आप कब यूज करते हैं? रजिस्टर, yes, कैरी चेन. ओके फाइन, बट इसको वेरिलॉग में हम क्या नाम से डिफाइन करते हैं? शायद कल हमने एक लिया था स्ट्रक्चरल में, शायद आप लोगों को याद भी होगा, जो एक मक्स ड्रॉ किया था. ओके, so mux, शायद if you are having this is a mux, 2:1 mux. Okay, A, B and what is that? It is a select line. This is a Y. So इसका हमने इंटरनल स्ट्रक्चर कैसे ड्रॉ किया था? We need S bar, है ना? We need S bar. This is S. Again, we are having this first AND gate. We are having a second AND gate. So there is A is connected, B is connected. The output of a first AND gate and second AND gate, that will be connected to your OR gate. So this is defined by C and D. अभी S bar को हम क्या बोलते हैं? That will connect between that output of your not connected with the AND input. इसको हम क्या बोलते हैं? Wire. Very correct. Very correct. When we connect two internal blocks by a signal, दैट इज नोन एज वायर, दैट इज नोन एज वायर। अभी यहां पे चेक करो, जो फुल एडर का सेकंड FA1 का जो ए है, फुल एडर का इनपुट ए, वो ए ऑफ वन के साथ में कनेक्ट हो गया, बी का बी ऑफ वन से कनेक्ट हो गया, सम का एस ऑफ वन के साथ में कनेक्ट हो गया, लेकिन सी इन और सी आउट को हमने डिफाइन ही नहीं किया कि वो किसके साथ में कनेक्टेड है। सो दैट्स व्हाई वी हैव टू टेक दैट। सो इनिशियली FA0 का जो रहेगा इनपुट, इसको हम बोलेंगे सी ऑफ जीरो। FA0 का जो इनपुट है उसको हम करेंगे सी ऑफ जीरो, एंड लेट अज्यूम दैट सी ऑफ जीरो इक्वल्स टू जीरो। ओके, देन सी आउट ऑफ FA0 दैट विल बी, FA0 का जो कैरी है वो कहां पे जा रहा है, FA1 के सीन को। सो इसको हम डिफाइन करेंगे बाय अ नेम इज सी ऑफ वन, इसको हम बोलेंगे सी ऑफ वन। FA1 का जो सी आउट है वो कहां पे ऐड हो रहा है, FA1 का सी आउट वो कहां पे ऐड हो रहा है, FA2 के सी इन को, सो जिसको हम बोलेंगे सी ऑफ टू, करेक्ट। एंड FA2 का जो आउटपुट है सी आउट, वो कहां पे जा रहा है, FA3 के इन को, सो दैट इज माय सी ऑफ 3। नाउ लेट मी नो C of 0, C of 1, C of 2 and C of 3. Do you find outside of this block? 4-bit adder के बाहर है कि अंदर है? Is it inside or outside? C of 0, C of 1, C of 2, C of 3. Inside. So when we use the variable in inside and that shows the connection between two blocks, it is known as, उसको हम क्या बोलते हैं? Yes? Anyone? उसको हम क्या बोलेंगे? Wire. Very correct. Very correct. So these are my wires. These are my wires. Okay. So what my wire name is? C. And what their range is? 3 down to 0. Any doubt? Any doubt? Okay. Now let me check. जो आपका 4-bit adder है, तो इसमें अब हम कौन सा कंपोनेंट यूज कर रहे हैं? इंटरनल ब्लॉक फुल एडर। सो इसका मतलब आपके पास में फुल एडर ऑलरेडी डिजाइन चाहिए। अग्रीड? अगर आपको 4-bit एडर जाना है तो आपके पास में ऑलरेडी क्या होना चाहिए? ऑलरेडी आपके पास में क्या होना चाहिए? full adder. Is it right? Because we are using 4 times. So when you write your Verilog program, you should have, first of all, you should have your full adder. सबसे पहले आपके पास में क्या होना चाहिए? Your full adder. So your first step is you have to design full adder. So your first step is you have to design their full adder. So what their inputs are? A, we can just B, okay. There the input is C. Then this is my sum, and it is my, I'm saying that C in, and it is my C out. Either you can show as C in or C out, whatever you can say. So let us assume this is my C in, because एक carry out है तो एक carry in रहेगा. अच्छा, इसका मॉडल हम कैसे लिखेंगे? मॉडल, so model, what model name is? Full underscore adder. Okay. Then what their inputs are? What their inputs are? Input, yes, A, comma B, comma C in. Okay. Then output. Output क्या है मेरे full adder का? Sum and C out. Clear? Okay. So ये full adder हम directly data flow modeling से भी बना सकते हैं. Okay. या फिर आप gate level modeling, or you may also go with that behavioral, whatever you want. So for easiest way, we are going here because we have to just cover that 4-bit adder, the Verilog program. So do you know that sum equation? Sum का equation क्या होता है? A XOR B XOR C in, and C out का A and B, B and C, C and A. Okay, so how we can write? Assign, what is that? Sum equals to A XOR B XOR C in. Any doubt? And second one, assign C out equals to, what is that? A and B, or what is that? B and C in, or what is that? A and C in. Very simple. Model in model. So why we are going for full adder? Because in 4-bit adder we are using full adder 4 times. So ये आपके पास में pre-design चाहिए. Full adder should be pre-designed. Clear? Any doubt? इतना समझ में आया क्या आप लोगों को? We are looking for 4-bit adder. We are looking for 4-bit adder. So 4-bit adder में आपको क्या चाहिए? We want full adder. So that's why we should design. इसका मतलब आपके इसमें full adder already design चाहिए. Clear? Now we are looking for the program of. अभी हम कौन सा प्रोग्राम चेक करने वाले? Full adder. Sorry, 4-bit adder का. So we are looking for 4-bit adder. So we are going for 4-bit adder. So let we are having the block diagram of your 4-bit adder. Again, I am just drawing the same one. Adder underscore 4-bit. We should follow the lexical conventions. Identifier name should be start with alphabets only. So what their inputs are? इसका input क्या है? A. And what their range is? 3 down to 0. It's a group of wires. So that's why it is a bus. What is my B? It's this my B. It is a group of wire 3 down to 0. Okay. Then output. Output क्या है इसका? S. Sum 3 down to 0. And another output is C out. Correct? Another output is C out. So how we can write their model? इसका model हम कैसे लिखेंगे? So very simple. Model. Okay. What is model name? Model name क्या है यहाँ पे? श्वेता, साक्षी, नितेश. What is the model name? पायल. Model name क्या है? You may find in the screen what we have written inside in the block. Adder underscore 4-bit. Very correct. It's not 4-bit adder. Nitish. We are designing 4-bit adder, but model name should be start with alphabet only. Okay. So it's a adder underscore 4-bit. Very, very correct. Very correct. So adder underscore 4-bit. Clear? Clear? Okay. So what their inputs are? हाँ, अभी आप मुझे बताओ कि इसका इनपुट क्या है? इनपुट कौन कौन से हैं? Can anyone tell me? Input A and B and S. S नहीं है ना? ऐश्वर्या, इनपुट कहाँ पे S दिख रहा है आपको? अभी आप क्या डिजाइन कर रहे हैं साक्षी? अभी हम डिजाइन कर रहे हैं 4-bit adder. So C in is not my input. यहाँ पे आपको जो ब्लॉक दिख रहा है, ओके, ये ब्लॉक में कहीं पे C in दिख रहा है क्या साक्षी? No. Okay, there is only, yes, there is only A and B. There is only A and B. अब इसमें भी आपका जो A है, तो ये कितना है? A is my 4-bit, not single bit. When we write input A, B, it understand it's a single bit. अगर मैंने सिर्फ इनपुट को A, B अगर लिखा, तो वो हो गया सिर्फ हमारा सिंगल बिट. आर यू गेटिंग दिस? समझ में आया क्या? यस कावेरी, दैट इज ऑफ योर A 3 down to 0, B 3 down to 0. लेकिन यहाँ पे हमारे जो इनपुट्स है वो कितनी बिट है? 4 बिट है. सो दैट इज नोन एज वेक्टर और इट इज नोन एज योर बस. सो बस को हम वेरिलॉग में कैसे डिफाइन करते हैं? सो बस को हम डिफाइन करते हैं input, okay, that is my your input port, then there is a range, number of bits. So input space 3 down to 0 and then variable name. इसका मतलब मेरा क्या हो गया? A हो गया 4-bit, A of 3 down to 0. Are you getting it? How to define in Verilog? Multi-bit number or multi-bit variable you can say, or bus. Yes, okay. Input space range 3 down to 0, then A. Again, we are having a second input also. So I am saying that comma B. clear? Then comma. What is my output? What is my output? Output is also 3 down to 0. And what my output is? First output is sum, that is S. I am defining by a letter is S. Okay, और मेरा कौन सा आउटपुट है? और मेरा कौन सा आउटपुट है? सी आउट. सी आउट कितने बिट का है? सी आउट कितने बिट का है? पायल, सी आउट कितने बिट का है? सिंगल बिट. वेरी करेक्ट श्रेणी. सो इसको हम कैसे डिफाइन करेंगे? सी आउट को कैसे डिफाइन करेंगे? कैन एनीवन टेल मी? ऐश्वर्या, नीतीश, खुशी, ऐश्वर्या, मयूरी, हाउ टू डिफाइन सी आउट? सी आउट को हम कैसे डिफाइन करेंगे? सी आउट इज योर आउटपुट पोर्ट. यस एनीवन? लेट मी नो. सी आउट 1 डाउन टू 0. 1 डाउन टू 0 का मतलब क्या होगा? सी आउट ऑफ 0 एंड सी आउट ऑफ 1. इट मीन्स इट्स अ 2. रेंज इज 1 डाउन टू 0 का मतलब हो गया 2. श्रीनी, इज इट करेक्ट? यस प्रणव, यू आर वेरी करेक्ट. आउटपुट सी आउट ओनली. आउटपुट अभी मैंने बताया ना, अगर आपने कोई रेंज अगर नहीं दी तो इसका मतलब क्या होता है? ओनली अ सिंगल बिट. एंड इफ यू प्रोवाइड द रेंज इट मीन्स इट्स अ बस. इज इट क्लियर? Yes. Okay, thank you. Now this is just a model and we will have that end models. This is my Verilog. But how it is made up? ये जो ब्लॉक है एडर 4 बिट का, ये कैसे बना हुआ है? तो इसके अंदर है 4 फुल एडर. क्लियर? और 4 फुल एडर के साथ में जो सी आउट आने वाला है वो रहेगा. फर्स्ट इसका सी आउट हो जाएंगे, सेकंड इसको सीन को, सेकंड इसका सी आउट हो जाएंगे, थर्ड इसको सीन को. एंड दिस इज सी ऑफ 0, सी ऑफ 1, सी ऑफ 2, सी ऑफ 3. ये ब्लॉक के बाहर की ब्लॉक के अंदर है. So it is inside in the block. So that's why we have to define these are C of 0, C of 1, C of 2, C of 3. इन सबको मेरे को क्या डिजाइन करना पड़ेगा? सॉरी, इन सबको मेरे को क्या डिफाइन करना पड़ेगा? C of 0 to C of 3, C of 0 to C of 3. इन सबको मेरे को क्या डिफाइन करना पड़ेगा? Can anyone tell me? Wire. Yes. So that's why we need here wire. We need wire. और वायर का नाम क्या है? C. वायर का नाम क्या है? C. और कितने बिट का है? आप C कितने टाइम्स यूज कर रहे हैं वहां पे? 4 बिट. वेरी करेक्ट. सो हाउ टू राइट इट? इसको हम कैसे लिखेंगे? We are using a same alphabet but index is C of 0, C of 1, C of 2, C of 3. Okay. So how to write it? Yes, anyone? Can anyone tell me? Correct. Very correct. Very correct. So wire 3 down to 0. Wire 3 down to 0. Any doubt? Any problem? Is that clear? Is that clear? Yes. Okay, thank you. Now, what here we are going to use? सबसे पहले चेक करो. हाँ, अगेन वी आर गोइंग बैक टू योर ब्लॉक डायग्राम. सो सबसे पहले यहाँ पे चेक करो, आपने C of 0 को क्या डिफाइन किया है? C of 0 इक्वल्स टू 0. सबसे पहले आपने क्या डिफाइन किया है? C of 0 को 0. C of 0 को हमने क्या डिफाइन किया है? 0. ओके. सो हाउ वी कैन राइट हियर इन द प्रोग्राम? हम इसको कैसे लिखेंगे यहाँ पे? So we just write that assign. What is my C of 0 is? C of 0 equals to, क्या डिफाइन किया मैंने C of 0 को? C of 0 को मैंने डिफाइन किया है 0. करेक्ट? वेरी करेक्ट. वेरी करेक्ट. ओके. व्हाट नेक्स्ट? उसके बाद में क्या है? यहाँ पे मैंने कौन सा ब्लॉक यूज किया है? दिस इज माय विच ब्लॉक आई एम यूजिंग हियर? व्हाट इज इट? दिस इज माय, यस एनीवन? व्हाट दिस ब्लॉक इज? कौन सा ब्लॉक यूज किया है? यस, ए ऑफ जीरो बी ऑफ जीरो कहां पे कनेक्ट है? कैन एनीवन टेल मी? कैन एनीवन टेल मी? fa0 वी कैन सी इंस्टेंस नेम। fa0 का मतलब क्या रहेगा? इंस्टेंस नेम। ओके, यानी फुल एडर हम 4 बार यूज कर रहे हैं और चारों के अलग अलग नाम है। fa0 इसका नाम है, इसका नाम है fa1, इसका नाम है fa2, इसका नाम है fa3। so that means same full adder 4 times we use, that means it's a 4 instances, fa0, fa1, fa2, fa0। खुशी s of 0 कहां से है बेटा? s of 0 खुशी a of 0 और b of 0 कहां पे कनेक्ट है? तो कनेक्ट है फुल एडर fa0 को। ओके, सो व्हाट हियर वी हैव टू एक्सेस। सो यहां पे आपको क्या लिखना पड़ेगा? यहां पे हमको लिखना पड़ेगा फर्स्ट फुल एडर। सो आपने जो फुल एडर डिजाइन किया था, आपने जो फुल एडर डिजाइन किया था उसका नाम क्या है? उसका नाम है फुल एडर। सो वी हैव टू यूज दिस फुल एडर फर्स्ट टाइम। सो व्हाट, हाउ वी कैन राइट इट? So that is my name is full adder, full underscore adder. Is it visible? Is that color is visible to you? Okay, I will use that dark color. Okay. So, okay, sorry. So what here? The name is full underscore adder. As it is used first time, so their instance name is taken as fa0. Okay, in bracket. Okay, we are doing their port mapping. अभी हम करने वाले हैं इसका port mapping. So port mapping कैसे करेंगे? Check it. So जो मेरा फुल एडर का A है वो किसको कनेक्ट है? यहाँ पे चेक करो। कैन एनीवन टेल मी? फुल एडर का जो A है वो किसको कनेक्ट है? कैन एनीवन टेल मी? यस एनीवन? साक्षी, खुशी, मंदार? A ऑफ 0, पायल, वेरी करेक्ट। A ऑफ 0 और B कहां पे कनेक्ट है? B ऑफ 0, करेक्ट। जब हमने फुल एडर बनाया तो उसका सीक्वेंस क्या था? ये सीक्वेंस चेक करो। उसका सीक्वेंस क्या था? सबसे पहले इनपुट है A, उसके बाद में है B, उसके बाद में है Cin, उसके बाद में sum and then Cout, so when we use full adder in 4-bit adder, we should know my full adder sequence. So full adder का जो मेरा सीक्वेंस था वो कैसा था? सबसे पहले है मेरे इनपुट, कौन कौन से इनपुट थे? A, B, C इन। उसके बाद में था मेरा आउटपुट में भी मेरा सम पहले था, फिर सी आउट था। आपको इसी सीक्वेंस से इनपुट देना है व्हेन यू यूज फुल एडर इन 4-bit एडर। सो इन 4-bit एडर, फुल एडर fa0, सो माय A विल कनेक्ट विथ, A को क्या कनेक्ट रहेगा? A ऑफ 0। ओके, सेकेंड सीक्वेंस क्या था? B, सो इसको हम बोलते हैं पोजिशनल मैपिंग। सेकेंड क्या है? B ऑफ 0। नाउ सी इन को क्या कनेक्ट है? कैन एनीवन टेल मी? सी इन को क्या कनेक्ट था? कैन एनीवन टेल मी? चेक इट फॉर सी इन को क्या कनेक्ट है? सी इन को क्या कनेक्ट है? यस एनीवन? C ऑफ 0, वेरी करेक्ट। और सम इज कनेक्टेड विथ S ऑफ 0, वेरी करेक्ट। एंड सी आउट चेक करो, सी आउट को क्या कनेक्ट है? कौन सा वायर कनेक्ट है सी आउट को? सी आउट को कौन सा वायर कनेक्ट है सी आउट को? C ऑफ 1, वेरी करेक्ट। सो व्हाट हियर? सो A ऑफ 0, B ऑफ 0, C इन, मेरे C इन को क्या कनेक्ट रहेगा? C ऑफ 0। सम को क्या कनेक्ट रहेगा? S ऑफ 0। और C आउट को क्या कनेक्ट रहेगा? C ऑफ 1। वेरी सिंपल। ओके, देन वी आर हैविंग अ सेकंड फुल एडर, इज इट राइट? सेकंड फुल एडर के A को क्या जा रहा? A ऑफ 1, B को B of 1, C in को चेक करो, C in को क्या जा रहा, C of 1, then sum को S of 1, C out को C of 2. So I am just writing it same. So I want to access what here we are going to design. मैं अभी यहाँ पे क्या डिजाइन कर रहा हूँ, 4-bit adder. तो मुझे कितने फुल एडर लगेंगे, 4. So full underscore adder FA, इसका नाम देंगे हम FA1. So A को कनेक्ट रहेगा मेरा A of 1, B को कनेक्ट रहेगा B of 1, C को कनेक्ट रहेगा C को कनेक्ट रहेगा C of 1, सम को कनेक्ट रहेगा S of 0, एंड C out को क्या कनेक्ट रहेगा, कैन एनीवन टेल मी, C out को सेकंड फुल एडर में, सेकंड फुल एडर में C out को क्या कनेक्ट है, यस एनीवन, यस एनीवन, व्हाट इज दैट, C of 2, very correct, C of 2. Okay, so it is C of 2, C of 2. Okay, only 5 ports are there, so bracket complete. Then full underscore adder FA2, what is that, A को क्या कनेक्ट रहेगा, A of 2, B को B of 2, C को C of 2, S को S of, it is S of 1, S को S of 2, and C out को C of 3. Okay, then full adder, fourth full adder, what their name is, FA3. हाँ, A को क्या कनेक्ट है, A of 3, B को क्या कनेक्ट है, B of 3, C को क्या कनेक्ट है, C इनको C of 3, सम को क्या कनेक्ट है, S of 3, एंड फोर्थ फुल एडर में C out को क्या कनेक्ट है, फोर्थ फुल एडर में C out को क्या कनेक्ट है, यस एनीवन, फोर्थ फुल एडर में C out कहां पे कनेक्ट है, FA3 का C out कहां पे कनेक्ट है, A3, B3, C3, S3, C out, very correct. This is the actual C out is connected. It is actual C out is connected here. Clear? It is actual C out is connected here. Very correct? Yes. Thank you. So here, this is connected with C out. The program is over. The program is over. Okay. Any doubt? Any doubt? How to write the program for 4-bit adder in structural way? So can we go for demonstration? Yes. Any doubt here? Is that clear, Sakshi? Yes. Okay. Thank you. Okay. Anything else you want other than this? Any doubts?